So here's the thing. A massive, perfectly circular hole just opened up in the middle of the Siberian Arctic tundra, and nobody can explain how it got there. At first, scientists thought it was just another sinkhole, like the ones that pop up in places with unstable ground or old mining tunnels. But this one? It's different. The walls are smooth, the rim looks like it exploded outward, and the whole thing is surrounded by a blast zone of earth and ice chunks flung in every direction. Imagine a crater that looks more like something from a meteor impact than a geological collapse. That's what this is. But there's no impact. No meteor. No seismic activity. Just a hole. Out of nowhere. The first time something like this happened was back in 2014. Locals spotted a yawning hole in the Yamal Peninsula, a region known for its frozen ground and extreme conditions. At the time, it caused a media frenzy. People speculated everything from methane gas explosions to secret military tests. But this new one? It's 4 times bigger. Over 100 feet wide and plunging deep into the earth, with a depth scientists haven't even been able to measure yet. Every drone they've sent in either loses signal or malfunctions. One of them came back with damaged propellers, like it had struck something in the dark. Now, let's talk about the terrain, because this is key. The Arctic tundra isn't exactly a forgiving environment. The ground is made of permafrost, soil that's been frozen solid for thousands of years. But here's the scary part. Permafrost isn't permanent anymore. Over the last few decades, rising global temperatures have been thawing it, slowly turning what was once a stable surface into a ticking time bomb of trapped gases, ancient microbes, and massive underground voids. Scientists have been warning for years that as the permafrost melts, methane, an incredibly potent greenhouse gas, could be released into the atmosphere. Methane is about 25 times more powerful than carbon dioxide at trapping heat, and the Arctic is full of it. Some researchers believe the pressure buildup from trapped methane pockets can cause sudden blowouts. But even that doesn't fully explain the shape and structure of these holes. Methane blowouts should be more chaotic, more irregular. These holes are disturbingly precise, like something drilled by a machine. That's the detail that's freaking out geologists the most. And it's not just the hole that's strange. Around the edges, researchers have found unusually high levels of radiation, not dangerous to humans, but higher than what you normally find in permafrost. They also detected odd electromagnetic pulses, which they originally chalked up to equipment glitches. But after 3 separate teams reported the same thing, they had to accept that something was interfering with their instruments. Some even theorized that the heat required to blast open a hole of this size would have melted the surrounding ice instantly. But there's no evidence of extreme temperatures. No burn marks. No charred soil. Just permafrost that's somehow been vaporized. A few brave researchers rappelled down into the edge of the formation before the walls started crumbling. They described an eerie silence down there, with the air becoming thick and heavy the deeper they went. One of them swore he saw movement deep below, like something was shifting under the ice, but the others dismissed it as stress or vertigo. Still, none of them stayed down for long. And then there's the biological angle. Samples collected near the rim revealed something weird. Frozen plant material that dates back over 40,000 years, perfectly preserved, and teeming with microbial life that's still viable. That's unheard of. Usually, when ancient ice thaws, you find degraded remnants. But these samples are alive. Some microbiologists believe these organisms haven't seen the light of day since woolly mammoths roamed the planet. Others are less optimistic, warning that releasing ancient pathogens could be like opening Pandora's box. After all, we have no immunity to something that hasn't existed in tens of thousands of years. The most bizarre theory, though, doesn't come from geologists or climatologists. It comes from physicists. One team from a Russian university proposed the idea that the Arctic hole might be the result of a localized gravitational anomaly, a sudden shift in the Earth's magnetic field that could, theoretically, cause matter displacement. Basically, the ground might have momentarily lost its structural integrity, collapsing into itself in an ultra-fast, ultra-concentrated implosion. That theory hasn't been peer-reviewed. Most scientists think it sounds like science fiction. But then again, so does a 100-foot wide perfectly round hole that opens up for no reason in the middle of frozen wilderness. What really pushed this into the realm of the unexplainable was what a satellite picked up 2 nights after the hole appeared. A thermal anomaly, a faint, but very distinct heat signature, was captured rising from the center of the hole. This wasn't just residual heat from a release of gas. The shape of the anomaly resembled a vertical column, like a thermal chimney, stretching up for almost a mile before dispersing into the atmosphere. No one has figured out how that's possible in a region that rarely climbs above freezing. And then it happened again. A second hole, smaller but just as circular, opened up 37 kilometers east of the first. Same structure, same blast radius, same electromagnetic disturbance. Except this one appeared in the middle of a remote Arctic lake. The ice cracked outward like spiderwebs, and the lake partially drained into the opening. Divers were sent to investigate, but none could descend beyond a certain point. They reported a strange humming noise underwater, one that grew louder the closer they got to the hole. The mission was called off after 2 divers experienced sudden disorientation and had to be pulled up. So what are we dealing with here? Methane explosions? Geological collapses? Magnetic anomalies? Or something we haven't even begun to understand? What makes this even more chilling is that the area where these holes are forming isn't just some random patch of tundra. It sits directly above one of the oldest and most unstable fault zones in northern Eurasia. Some believe that stress along this fault line, combined with melting permafrost, could be creating unstable pockets beneath the surface, giant voids waiting to collapse. Others think these are natural release valves for something building up below. There are whispers in certain scientific circles of an ancient reservoir deep under the ice, something sealed off since the last ice age. A reservoir not just of water, but of energy, pressure, and possibly life forms that evolved in total isolation. And if that's true, then these holes might not be the end of the story. They might be the beginning. Before we continue, I encourage you to consider subscribing to the channel and liking the video. Now, back to the video. At first glance, the hole looked like something had erupted from beneath the earth with such force and precision. It carved through layers of ancient ice and soil like a hot knife through butter. Perfectly round, rimmed with jagged ice, and deeper than anything that should have formed naturally in such a remote, frozen place. There were no signs of impact from above, no traces of external interference. Just a void in the earth where, quite literally, solid ground had given way to nothing. And so, naturally, scientists began to question, what could cause such a thing in the heart of the Arctic? The first and most unnerving theory to surface, and one that refuses to be dismissed, is this: a violent explosion, not from magma or tectonics, but from methane gas, silently building beneath the surface until the pressure becomes too much. This isn't some far-flung guess. It's rooted in hard science, and it begins with the nature of permafrost itself. Permafrost is, in the simplest terms, ground that has remained frozen for 2 years or more. But in the Arctic, we're not talking about a few years. We're talking about tens of thousands. During that time, layer upon layer of organic material, dead plants, ancient moss, even the remnants of prehistoric animal matter, has been frozen in time. Trapped in ice, sealed in a kind of cryogenic pause. On the surface, it's a wasteland of snow and wind. Beneath that, though, lies a delicate ecosystem that has been preserved for millennia. And here's the catch: that organic matter doesn't just disappear. It's still very much there, lying dormant, held in check only by the cold. But as the climate shifts and Arctic temperatures creep higher each year, the ice that encases all that biological material starts to thaw. Slowly at first. Just a degree here, a fraction there. But in the Arctic, those changes are magnified, warming twice as fast as the global average. And with each passing summer, the frost line retreats deeper and deeper. Once thawed, those ancient materials don't stay inert. They begin to decompose. Microbial life, long frozen, begins to stir. And in the absence of oxygen, those microbes generate methane, a greenhouse gas more than 25 times more potent than carbon dioxide when it comes to trapping heat in the atmosphere. This methane doesn't immediately rise to the surface and escape into the sky. Often, it becomes trapped beneath still frozen layers above, forming invisible pockets of gas. Think of it like inflating a balloon underneath a concrete floor. The pressure builds, but the surface holds. At least for a while. Eventually, the frozen cap becomes too thin, too weak, or too fractured to contain the mounting force beneath it. Then, in a single moment, it gives way. The result? A sudden, catastrophic gas explosion. Earth and ice are violently ejected, sometimes scattered hundreds of feet in every direction. What's left behind is a deep, round crater, raw, gaping, and disturbingly clean cut. No lava. No ash. Just a void where pressure once reigned. These kinds of blowouts have already been recorded in parts of northern Siberia, where gas craters shocked scientists when they were first discovered a decade ago. Locals reported hearing distant booms, like thunder rolling beneath the ice. One such crater was nearly 100 feet wide and over 200 feet deep. When researchers arrived, methane concentrations were off the charts, dozens of times higher than typical background levels. But this latest hole in the Arctic is different. It's not in Siberia, and it didn't occur where past blowouts had been studied. This one formed in a zone long believed to be stable, deep Arctic permafrost that, according to models, shouldn't have thawed for another 50 years. That's what makes it so alarming. There were no obvious signs of warming, no gradual surface buckling that usually signals a gas pocket beneath. Just one day, solid ground. The next day, a hole. And not just any hole, one with smooth, inward tilted walls, suggesting a sudden inward collapse following an upward burst. Scientists rushed to gather data, but extreme conditions made it nearly impossible to reach immediately. Drones provided the first images, and what they revealed only deepened the mystery. There was little surface disturbance around the rim, no signs of prolonged melting, no visible warping or water runoff. It was as if the Earth had simply opened from below. Which brings us to the uncomfortable part. If methane caused this, how did it build up so rapidly in a region where it shouldn't have existed yet? Was it truly thaw-induced microbial methane? Or is there something deeper happening? Some researchers now wonder whether thermogenic methane, that is, gas originating from deep geological reservoirs, might be migrating upward through the crust. In other words, this wasn't just a case of thawing vegetation creating gas. It might have been a rupture in a long-buried, ancient gas vein. If true, that would mean the Arctic is not just warming, it's shifting geologically. That kind of movement could allow methane to slip through rock layers, rise undetected, and accumulate beneath shallow permafrost layers that, up until recently, had seemed impenetrable. This possibility is chilling. Because if this isn't a one-time freak event, if deeper gas systems are starting to leak upward, we may see more of these holes appear. Not in decades, but in years, maybe even months. And they won't necessarily be in remote areas. They could form near scientific outposts, shipping routes, or even small Arctic communities. What makes this all the more troubling is the feedback loop. Methane, once released, accelerates climate change, which in turn melts more permafrost, which releases even more methane. The Arctic, once a frozen time capsule, could become a climate bomb, a self-feeding cycle of thaw and release. This hole may not just be a symptom, it could be a warning. And yet, there's so much we still don't know. No sensors picked up the event before it happened. No thermal data predicted the location. It happened in silence. And when it opened, it did so with precision, as if the Earth had planned it. One question lingers, echoed across research stations and field tents. How many more of these gas chambers lie just beneath our feet, waiting for the right moment to erupt? The most unsettling part of this theory isn't just the idea that methane gas can violently rip through frozen ground. It's the realization that we may have vastly underestimated just how volatile the Arctic has become, and how little we truly understand about the forces stirring beneath its surface. As researchers began analyzing satellite data from the weeks leading up to the crater's appearance, they noticed something odd: subtle fluctuations in ground temperature that weren't visible in broader climate models. These temperature spikes didn't last long, sometimes no more than a few hours, but they were just enough to temporarily weaken the upper layers of the permafrost. It's as if the land was breathing, inhaling heat in pulses, then freezing over again. The question is, what's driving those pulses? One possible explanation lies in subsurface convection, a process that's rarely discussed outside of geological circles, but might hold the key to what's happening here. In areas where permafrost is deep, thawing doesn't always begin from the top down. Instead, warm groundwater moving beneath the Earth's crust can slowly circulate upward, distributing heat from below in an unpredictable pattern. These thermal plumes, invisible to the naked eye, can weaken large volumes of ice without raising surface temperatures enough to trigger alarms. It's a stealthy form of erosion, slow and silent, until the structure collapses. If this mechanism is active beneath the Arctic, it means methane pockets are being destabilized not just by external warming, but by internal heat fluxes. And that's a much more difficult force to track. Climate models are designed to monitor atmospheric trends, not under ice convection or geological heat migration. This internal heating could explain why the hole formed so suddenly, and why there were no warning signs on the surface. Even more chilling is the pattern that some scientists are beginning to notice. When they plot the locations of known gas craters, particularly in Siberia, and overlay them with geothermal anomaly maps, a disturbing correlation emerges. Many of these craters sit atop regions where ancient fault lines intersect with permafrost basins. These fault lines aren't active in the traditional seismic sense, but they do allow for the slow movement of deep earth gases and heat. It's like nature's pressure valves, underground corridors where energy can escape in unexpected ways. And that brings us to a critical point. If these faults are conduits for methane migration, then this isn't just about climate change anymore. It's about geological vulnerability. The Arctic isn't just melting. It may be cracking from within. New drilling data from exploratory wells in northern Greenland, collected long before this latest event, suggests there may be massive reservoirs of trapped methane far deeper than previously believed. These deposits are remnants of ancient seabeds, formed millions of years ago when the region was a lush, subtropical expanse. Over the eons, pressure forced the gas into deep pockets, sealing them beneath layers of ice, sediment, and rock. As long as the permafrost stayed intact, those pockets remained stable. But now, all bets are off. With each passing year, the Arctic loses more of its insulating ice. The land becomes more permeable, more vulnerable. Small cracks form. Then, thermal expansion widens them. Before long, gas once buried for millions of years finds a path upward. This leads us to a terrifying possibility that a handful of researchers have begun whispering about: chain reactions. If one gas pocket erupts violently enough, could it destabilize neighboring pockets? Could the shockwave ripple outward, cracking the fragile permafrost structure like glass under tension? We don't have enough data to say definitively, but the physics make it plausible. After all, underground explosions don't just create craters, they send shockwaves through soil and stone. Imagine a scenario where one eruption sets off a sequence of subsurface failures, gas chamber after gas chamber collapsing and exploding in quick succession. The Arctic could, in theory, become a vast network of ticking time bombs. Each one hidden, each one capable of tearing the landscape apart in an instant. And here's another concern: feedback amplification. The gas released by these blowouts doesn't just disappear into the wind. It lingers in the atmosphere, contributing to further warming. In fact, studies show that atmospheric methane levels are rising faster than at any point in recorded history, and a portion of that increase is believed to be coming from high-latitude emissions. The very act of one explosion might accelerate the conditions that trigger the next. What's worse is how little we can do to prevent it. We can't build pressure valves into frozen tundra. We can't seal underground gas pockets from the surface. And perhaps most disturbingly, we can't see these pockets before they become a problem. ground-penetrating radar has limitations. Satellite imaging only reveals surface changes. Until now, our methods of monitoring Arctic instability have focused on gradual processes: glacial melt, ice sheet thinning, erosion. They were not designed to detect violent, subterranean gas ruptures. Yet here we are, faced with a hole that defies our expectations, carved by a force we knew existed but didn't fully understand. As one Arctic researcher recently put it, it's like finding a landmine in the middle of a glacier and realizing it's not the only one. So the methane explosion theory continues to dominate the discussion, not just because it fits the physical evidence, but because it raises bigger, more disturbing questions. Questions about hidden systems of pressure, about invisible networks of trapped gas, and about just how fragile the ground beneath our feet may have become. And as researchers scramble to install new sensors, run emergency simulations, and map potential danger zones, there's a growing sense that we've only just scratched the surface, literally. While the methane theory still holds the lead in scientific circles, a growing number of researchers are beginning to whisper about another unsettling idea. One that doesn't involve explosive gas or pressure chambers hidden beneath the permafrost, but instead centers around ancient geological instability. It's a theory that takes us even deeper into the Earth's crust, challenging our assumptions about what's supposed to be solid, unmoving ground. The theory suggests that what we're seeing may not be the result of an eruption from the Arctic, but rather a subsidence into it, a collapse driven not by gas, but by the very ground itself giving way under shifting tectonic conditions. This process, known as permafrost sinkhole formation, sounds benign at first. But once you examine the mechanics of it, it becomes clear this isn't your average pothole. This is something far more complex, something that could indicate a deeper destabilization of the Arctic lithosphere itself. Let's break it down. The Arctic is underlain by vast deposits of what's known as Eudoma permafrost, a highly organic, ice-rich form of frozen soil that was laid down during the late Pleistocene epoch. For tens of thousands of years, these sediments have remained locked in time, preserving not just plant matter and microbial life, but also the integrity of the landscape above. Eudoma is peculiar in one very important way: it's incredibly vulnerable to thermokarst activity, a process where ice-rich ground thaws, loses volume, and causes the surface above to sink dramatically. Now, here's where it gets even more interesting. For years, scientists believed thermokarst processes occurred gradually, small collapses here and there, forming ponds and depressions over decades. But new data from satellite radar altimetry has shown something unexpected. In certain remote zones of the Arctic, land surface elevation can drop by several feet in a matter of weeks. This is not gradual melting. This is collapse. Sudden, deep, and violent. And this brings us to the new theory. What if the mysterious Arctic crater isn't the product of an upward force, but rather a downward void collapse, an implosion caused by the rapid melting of a deep subsurface ice lens that once supported the overlying terrain? In this scenario, a giant ice wedge or frozen underground cavern, possibly formed during the last ice age, suddenly destabilized. As warmer groundwater infiltrated it from below, the structural integrity of that ice mass rapidly degraded. Unlike normal soil, which compacts and settles slowly, permafrost held together by ancient ice can lose cohesion in an instant when thawed. That means instead of slowly sinking, the surface can suddenly plummet, creating a gaping hole where moments before the land appeared intact. Supporting this theory is a strange piece of field evidence that hasn't gotten much public attention: lack of ejected material around the rim of the crater. When an explosion occurs, whether from gas or pressure release, debris is typically scattered outward: soil, rock, ice fragments. But at this site, researchers noted a suspicious absence of scattered ejecta. Instead, it looked like the land had been sucked inward, almost like the earth had inhaled. And that brings us to a bizarre parallel: karst sinkholes, which are common in limestone regions where water dissolves bedrock and causes sudden collapses. The Arctic isn't made of limestone, but what if a similar principle applies? In the case of permafrost karst, the dissolving agent isn't acidic water, it's heat. Not necessarily from the atmosphere, but from within. Subterranean heat flows that gradually melt supportive ice structures from the inside out, until the weight of the overlying ground causes everything to cave in. What makes this so disturbing is the potential unpredictability of it. These collapses don't need fault lines or pressure buildup. They just need a pocket of hidden ice, a bit of thermal fluctuation, and a load-bearing surface above. In other words, this could happen almost anywhere in the Arctic, at any time. And it raises a terrifying follow-up question: how many of these voids are out there, just waiting? Our current mapping tools can't penetrate deeply enough to detect underground ice structures unless they're actively melting. Which means we may be walking, or building, over ticking geological voids, unaware until the ground beneath us gives way. To make matters worse, the Arctic is now experiencing an increasingly erratic seasonal thaw cycle. In recent years, periods of midwinter warmth followed by sudden refreezing have become more common. This constant freeze-thaw seesaw isn't just an inconvenience for wildlife or weather, it fractures the internal structure of the permafrost, much like repeatedly bending a frozen twig. Eventually, it snaps. Some climate scientists have even floated the possibility that the crater could mark the beginning of a larger structural degradation of Arctic terrain. If enough ice-rich areas begin collapsing in similar fashion, the region could experience a kind of topographical reformation, where lakes, rivers, and landforms shift dramatically within just a few decades, rather than centuries. But perhaps most alarming is that this theory, while geologically grounded, offers no clear mitigation strategy. You can't predict the location of an invisible void. You can't stop subsurface ice from melting once the heat has found its way in. And you certainly can't reinforce the land above when it's spread across millions of square kilometers. So while the methane theory captures the imagination with its dramatic flair, this sinkhole hypothesis may be even more unsettling, because it suggests that the Arctic is quietly, invisibly rotting from the inside, collapsing under its own ancient weight. One moment, the ground is frozen, stable, timeless. The next, it's gone, swallowed into a darkness we never saw coming. While the notion of ground collapse due to melting permafrost already seems concerning on the surface, what's unsettling is how much of this process is happening undetected beneath our feet. You see, one of the major challenges in studying Arctic terrain is that traditional geological tools, seismic readings, ground-penetrating radar, thermal scans, are only intermittently effective in regions where frozen water is intermixed with organic material, mineral sediment, and shifting brine layers. This complex layering acts like insulation, shielding the deeper anomalies from being properly observed until it's too late. Researchers have started referring to some of these subsurface structures as frost coffins. These are long-buried ice formations encased within sediment and organic matter, some of which have remained untouched since the end of the last glacial period. The name is metaphorical, but unsettlingly appropriate. They preserve fragments of the past, but they also threaten to become sites of sudden and irreversible collapse. Unlike typical ice wedges that thaw gradually, these frost coffins are susceptible to asymmetric thawing. In other words, heat creeps in from one side, often from the bottom upward, creating a hollowed-out structure long before the surface shows any signs of distress. Once that interior cavity reaches a critical size, a catastrophic collapse becomes inevitable. Adding to the intrigue is how hydrological shifts in the Arctic are influencing this process. As warmer temperatures lead to deeper seasonal thawing, meltwater starts to percolate through the soil, finding pathways downward through ancient fissures or newly formed thaw tubes. In some regions, scientists have discovered that this percolation isn't random. It seems to be guided by subtle electrochemical gradients in the soil, possibly left behind by long-dead microbial colonies or the magnetized remnants of ancient mineral deposits. These pathways may be funneling warmth directly into vulnerable underground ice formations, accelerating their collapse from within. To make matters worse, when these voids open suddenly, they often don't behave like textbook sinkholes. In many cases, they're neither symmetrical nor shallow. Instead, they form massive, vertical shafts, some as deep as 10 stories, with steep walls and jagged edges that suggest not a gentle sinking, but a violent snapping. Almost as if the earth itself fractured from the inside. tearing open like a wound. This aligns with what field researchers have witnessed at the site: walls of ice and ancient soil, perfectly preserved on the inside of the crater, as if a cross-section of history had been revealed in an instant. One scientist who visited the site described it as walking into the mouth of the past. Not just because of the layers visible in the crater walls, but because of what the collapse represents: a sudden rupture between what we assume to be permanent and what is actually fragile and transient. There's another layer to this theory that hasn't yet made headlines, but it's stirring interest in deep geological circles: the possibility that these collapses are tied to tectonic microflexures caused by post-glacial rebound. After the last ice age ended, much of the northern hemisphere began a slow, barely perceptible rise, a response to the immense weight of ancient glaciers lifting off the crust. In most places, this rebound is measured in millimeters per year. But in certain Arctic zones, this process is irregular and punctuated, meaning that instead of steady uplift, the land sometimes shifts abruptly. Now imagine this: a massive block of Eudoma permafrost with a delicate ice lens at its base. An unstable tectonic nudge, just enough to create hairline cracks. Those fissures provide a path for heat or moisture to enter. That's all it takes. Within weeks, a collapse begins. Not from weather, not from climate, but from a millennia-old shift beneath the surface, still echoing from the last time the Earth emerged from an ice age. These theories aren't mutually exclusive either. Scientists are beginning to consider the possibility of compound triggers, where subsurface melting, tectonic flexure, and thermal water infiltration combine in a cascade. In that scenario, the Arctic isn't just weakening due to climate change, it's unraveling from a series of ancient dominoes finally reaching their tipping point. And still, one of the most haunting aspects remains unanswered: why now? Why are we seeing such sudden and pronounced crater formations in the last decade? Is it simply the accelerating pace of Arctic warming, or is there an even deeper timing mechanism, something geologically cyclical that we have yet to decode? There are whispers among a few geologists of a thaw threshold, a point at which the Arctic reaches a tipping state, not linearly, but exponentially. Think of it like phase change. Ice doesn't gradually become water, it remains solid until the moment it liquefies. Likewise, permafrost may remain stable until just enough of it thaws to cause cascading collapses across vast regions. What we're seeing in this mysterious Arctic hole may be the first visible breach in a much larger, slower collapse. And the eerie part? We may not be able to predict where the next one will appear, or how large it will be. While most scientists remain tethered to geological models and climatological shifts, not everyone is satisfied with those conventional answers. There's a growing whisper among a fringe, but surprisingly credible, subset of researchers that this hole may not be the result of collapsing Earth, melting ice, or erupting gases at all. Instead, they suggest we might be witnessing the surface expression of something not from above or below, but from within. The speculative theory gaining traction in this circle proposes something that sounds almost like science fiction: a deep Earth anomaly or artificial construct, potentially not of natural origin, emerging in the Arctic due to tectonic shifts or unknown triggers. In simpler terms, some are asking whether this hole could be a man-made or intelligently designed shaft, intentionally created for reasons we can only begin to guess at. Now, before dismissing it entirely, consider this: the Arctic has long been one of the least explored regions on the planet. Beneath its ice lies a vast, mostly uncharted terrain, hundreds of miles of bedrock and ancient geology that satellites can barely penetrate, and that ground teams have rarely touched. Seismic scans of the region often come back fuzzy, inconsistent, or simply blank, leading some to believe there's something down there that doesn't reflect energy the way normal rock does. A material that's not ice, not stone, not gas, something else. It's here that the speculative theory gets stranger. Some believe this mysterious Arctic hole could be an access point, a vertical shaft either created recently or re-exposed by the shifting permafrost. The idea is that there may be an ancient structure or device buried deep beneath the Earth's crust, lying dormant for millennia, and only now, under specific environmental triggers, Is it beginning to activate, or worse, surface? This hypothesis often circles back to strange satellite anomalies recorded in the area over the past few years. Occasionally, satellites passing over this particular section of the Arctic reported brief electromagnetic spikes, subtle enough to ignore at the time but persistent across different orbits and different instruments. Initially attributed to solar interference, these glitches didn't occur anywhere else, only over a small radius surrounding the eventual location of the hole. That zone has since earned a quiet nickname among independent researchers, Sector 7, a nod to the unmarked, off-grid nature of the land and its frequent omission from declassified Arctic research maps. Now add to that another strange detail, the shape of the hole. While natural craters and subsidence pits typically form with uneven, jagged edges due to the chaotic nature of collapse, this Arctic anomaly was described by drone footage as nearly symmetrical, with vertical walls and an almost cylindrical bore. The first geologist on the scene said it looked less like something that collapsed and more like something that was drilled, with precision. A few theorists, borrowing ideas from ancient astronaut hypotheses and alternative archaeology, suggest that what lies beneath might be an ancient machine or vault, something buried intentionally long ago, either by a forgotten civilization or by entities far more advanced than our own. And while mainstream science is quick to dismiss these ideas, history offers odd parallels. Take the Tunguska event in 1908, a massive explosion in Siberia that flattened nearly 800 square miles of forest. To this day, no definitive cause has been proven. Some theorize it was a comet or asteroid that never left an impact crater. Others believe it was an airburst. And still others think it may have been the result of an underground anomaly discharging energy upward, not unlike the hole we're now seeing. So, if we take that leap, if we entertain the idea that this isn't just a geological incident, what might it mean? One possibility is that this is not the first such hole, but merely the first one we've noticed. Remote areas of the Arctic are so isolated and inhospitable that dozens of similar shafts could have appeared unnoticed. The theory continues, these holes could represent a kind of network, a grid of access points or exhaust ports to something vast and hidden beneath the Earth's crust. A construct. A vault. A mechanism. The speculative narrative suggests that environmental changes, like glacial melt, seismic shifts, or rising global temperatures, may be accidentally triggering ancient systems not meant to be disturbed. Systems that were designed to remain hidden. Or asleep. And then, there's the sound. Though unconfirmed, several reports from nearby research outposts describe hearing low-frequency humming or vibrations in the days leading up to the hole's appearance. Not seismic tremors. Not gas releases. But a consistent, almost mechanical tone, like a distant turbine or oscillating engine, heard just beneath the range of human hearing. Those who experienced it claim it felt less like a noise and more like a presence, something resonating through the body, like standing near a massive generator. Is it all coincidence? Misinterpreted data? Or are we brushing against the edge of something our current science isn't equipped to explain? Either way, the mystery deepens. Because if this hole is not natural, if it was created with purpose, then the next question is chilling. What was it meant to contain? Or release? Let's now transition into the potential implications this mysterious hole in the Arctic permafrost could have for humanity. If the hole is indeed something more than a natural occurrence, whether due to an unknown environmental anomaly, an ancient structure, or something else entirely, the consequences for the world could be profound. This isn't just a passing curiosity or a distant anomaly. This could represent a warning or a discovery of immense significance. Let's explore this carefully, diving into the speculative yet fascinating implications. If the mysterious hole in the Arctic is truly a product of something more intelligent, deliberate, or even ancient, the ramifications could be nothing short of revolutionary. We are talking about a discovery that could alter the course of human history as we know it. Imagine for a moment if this hole is not just a singular event but part of a much broader pattern, one that humans have not yet begun to understand or interpret fully. What would that mean for our world? At its core, this discovery would transform our understanding of both geology and engineering. For centuries, we've relied on models that explain the Earth's structure in relatively simple terms: tectonic plates shifting, volcanic activity, the erosion of ice, and more. But what if we're missing something deeper, more complex, and far more advanced than anything in our textbooks? Consider the implications if this hole is a man-made shaft created by a civilization long forgotten, or perhaps by extraterrestrial beings with technology that outpaces anything we could fathom. Imagine the knowledge we could gain about advanced construction techniques and materials that withstand extreme conditions. How could these insights transform our own building practices, especially as we venture further into the exploration of Mars or attempt to build sustainable cities in harsh environments? Furthermore, the materials and technologies we might uncover could have a ripple effect across all industries, from energy production to communications to transportation. A simple hole in the ice could lead to the revelation of new sources of energy, communication technologies, or even new forms of transportation that defy the physical limitations we currently understand. The shift from a planet-bound mindset to a cosmic one would also radically alter how we perceive our place in the universe. If evidence of extraterrestrial involvement were discovered, the idea of humanity's unique status in the cosmos would be shattered. Suddenly, we would be forced to confront the reality that we are not alone, that there are forces far beyond our comprehension that may have shaped our planet, or that we may be part of something far bigger than we ever dreamed. On a more immediate level, the discovery of such a hole could trigger global environmental consequences. The Arctic, with its delicate ecosystem, plays a pivotal role in regulating the Earth's climate. The region's melting ice sheets and shifting permafrost have already been linked to rising sea levels and unpredictable weather patterns worldwide. But what if the hole in the ice, whether it's naturally occurring or artificially created, represents an unseen destabilization beneath the surface? If this hole is somehow connected to the release of ancient gases, biological entities, or radioactive material, the environmental ramifications could be catastrophic. The release of methane or other greenhouse gases trapped in the ice for millennia could significantly accelerate the pace of global warming, pushing temperatures beyond what our ecosystems can handle. Even more unsettling is the possibility that this hole could be the harbinger of something yet unknown, an underground force that, once disturbed, triggers unpredictable and dangerous feedback loops within the global climate system. On the other hand, if the hole is part of an artificial or ancient system, one designed to interact with the Earth's environment in a controlled way, it could provide us with a unique opportunity to learn how to manipulate natural forces in ways that we currently can only dream of. Imagine if this was the key to unlocking climate stabilization technologies, or if it offered an unprecedented means of global resource management. The potential to control or manipulate the Earth's environment on a planetary scale would fundamentally alter humanity's future. The discovery of a mysterious anomaly in the Arctic would almost certainly lead to a geopolitical scramble. Countries with Arctic territories, Russia, Canada, the United States, and others, would immediately recognize the value of the region, not just for its natural resources but also for any potential technological advancements hidden beneath the ice. We could be on the verge of a new Cold War, but this time, it would be a race for control over access to this enigmatic site. Nations might compete to secure research bases, sabotage one another's efforts, or even stage covert operations to try to unlock whatever secrets this hole might hold. The stakes would be enormous. Whoever controls the knowledge or technology hidden beneath the surface could have the power to reshape the global balance of power. Additionally, the military implications would be profound. Governments would undoubtedly want to explore whether the hole is a strategic entry point, a security threat, or potentially even a weaponized feature, something designed with defense or offensive capabilities in mind. The mere possibility that a new and unknown force could be used to exert control over global systems would prompt nations to quickly reassess their defense strategies and international alliances. Beyond the material, practical, and geopolitical consequences, the existence of such an anomaly would have a deep psychological impact on humanity. How would we cope with the realization that there is so much more about the world, and perhaps the universe, than we ever imagined? For centuries, humanity has tried to unravel the mysteries of the world, only to find that more often than not, the questions we ask lead to even deeper questions. The hole in the Arctic could serve as a catalyst for a global existential crisis, pushing people to confront philosophical and spiritual dilemmas. How do we reconcile the idea that there may be forces or intelligences far older, wiser, or more powerful than us? Would this cause a shift in religious perspectives, as people grapple with the possibility that humanity is just a small part of something vast and cosmic? In parallel, it could also be a unifying force. People from different countries, cultures, and backgrounds might find common ground in the shared experience of confronting something so beyond our comprehension. Instead of dividing us, the whole might bring us closer together, fostering a new era of collaboration and shared purpose as we try to understand its mysteries and harness its potential. The discovery of a mysterious hole in the Arctic permafrost, whatever its origin, would challenge our assumptions about the Earth, our technology, and our place in the universe. The implications would reach far beyond the scientific community, touching every aspect of human life, from global politics to personal beliefs. As we come to the conclusion of this exploration into the mysterious hole opening in the Arctic permafrost, it's clear that this phenomenon, though still largely unexplained, has sparked a wealth of questions, theories, and ideas that touch on various realms of science, speculation, and even philosophy. The more we delve into the potential causes and implications, the more we realize how much is still unknown about the Earth, its history, and its future. To begin, we examine the potential natural causes behind the hole's formation. Could it simply be a result of natural processes? The Arctic permafrost is a region of extreme cold and complex geological activity, with changes in temperature, ice dynamics, and gas releases causing unpredictable effects. The theory of an underground methane leak, or the melting of subsurface ice triggering the opening of a fissure, fits into a relatively more plausible narrative. Such events, though rare, are still consistent with our understanding of how Earth's natural systems operate. The Arctic, with its vast and unexplored areas, provides a stage for these phenomena to unfold, unpredictable, awe-inspiring, and at times catastrophic in their scale. The idea that thawing permafrost could reveal hidden gases or ancient remnants adds a layer of complexity to the scenario. These gases, particularly methane, could have catastrophic effects on the global climate if released in sufficient quantities, rapidly accelerating the global warming process. It's unsettling to think that a simple shift in temperature could trigger a cycle that impacts us all, but it is within the realm of possibility that this hole is a manifestation of such a process. Yet, as we continued to investigate the anomaly, we moved beyond natural causes into the realm of more speculative explanations. One theory that captured the imagination was the idea that this hole could be evidence of alien involvement, or even a secret structure hidden beneath the ice. The Arctic, with its harsh, inhospitable environment, has long been a subject of speculation for those looking for answers to life's bigger questions. Could this hole be a remnant of an ancient civilization, either from Earth's past or from beyond our planet, designed to manipulate the Earth's environment in ways we don't understand? Such a theory, though undoubtedly controversial and speculative, opens the door to wild ideas that have fascinated people for generations, from extraterrestrial lifeforms influencing our world to ancient technologies that still lie dormant beneath the ice. The notion that we might be on the cusp of a groundbreaking revelation, one that could fundamentally alter humanity's understanding of its place in the cosmos, adds an air of mystery to this whole scenario. What if this hole is part of a system far older than humanity itself, one that has remained hidden, awaiting discovery? As we venture deeper into these ideas, we acknowledge that, whether plausible or far-fetched, the hole in the Arctic permafrost could be the precursor to a monumental shift in how we view the world. The idea that this anomaly is a gateway to knowledge, or perhaps a warning from a higher intelligence, is undeniably intriguing. What if the forces at play here are far beyond our current comprehension, influenced by mechanisms or entities that transcend our understanding of the physical world? The implications of such a discovery would be both scientific and existential. It would force us to question everything we thought we knew about technology, history, and even our own origins. Moving beyond the purely speculative, we then turned our attention to the broader geopolitical and environmental implications. If this hole is truly linked to something more significant, whether a natural resource or a technological discovery, its discovery would spark a global race for control. Nations, particularly those with Arctic territories, would quickly realize the value of the site, not just for potential scientific discoveries, but for the technological advancements it could unlock. The mere fact that such a mysterious and unprecedented phenomenon exists in the Arctic would send nations into overdrive, scrambling to secure access to the site, understand its nature, and perhaps even harness its power for strategic gain. The geopolitical implications of this discovery would be immense, far beyond the typical competition for natural resources. It could lead to new alliances or new tensions on the global stage, as countries vie for access to what could be the key to an entirely new era of technology. Additionally, the environmental consequences of such a phenomenon cannot be overstated. The Arctic region is crucial in regulating the Earth's climate, and any disturbance to the balance of the ecosystem could send shockwaves around the globe. If the hole's origins lie in the release of greenhouse gases, particularly methane, from thawing permafrost, the environmental toll could be catastrophic, further accelerating the warming of the planet. The Arctic is already experiencing rapid changes, and the loss of ice and the potential release of trapped gases could create a feedback loop, intensifying global climate change and causing unpredictable weather patterns worldwide. On the other hand, if the hole were a gateway to understanding climate regulation mechanisms, it could unlock new technologies or techniques to mitigate the effects of climate change, giving humanity a fighting chance in the face of rising global temperatures. As we move into the realm of humanity's psychological and philosophical responses, it's clear that the discovery of such an anomaly would have deep and far-reaching effects on how we perceive ourselves in the grand scheme of existence. If this hole turns out to be connected to something alien, ancient, or unknown, it would shatter the notion that humanity is the apex of intelligence on Earth, or in the universe. This revelation could inspire both awe and fear, leading to existential questions that challenge religious, spiritual, and scientific beliefs. How would humanity cope with the realization that there are forces or intelligences beyond our comprehension? Would we unite under the shared goal of understanding this phenomenon, or would we fracture as nations and cultures interpret the event through different lenses? The idea that this mysterious hole could represent a defining moment in human history, one that sets the stage for a new chapter in our development, introduces an unprecedented sense of urgency. Humanity would have to decide whether to approach this discovery with cooperation or conflict, and the way in which we handle this moment could define the future of our species. Will we come together in the spirit of inquiry, seeking to learn and adapt, or will we be driven by fear, suspicion, and the desire for control? The choices we make in response to this anomaly will reverberate throughout history. In conclusion, the mysterious hole in the Arctic permafrost is more than just a scientific curiosity. It is a symbol of the vast unknowns that still lie beneath the surface of our world. Whether it is a natural phenomenon, a remnant of an ancient civilization, or an alien artifact, the implications of this discovery are enormous. It challenges our understanding of the Earth, our place in the universe, and our ability to control the forces of nature. As we continue to explore this anomaly, we must remain open to the possibilities, for this could be a moment that alters the course of humanity forever. In the end, perhaps this hole is not just a mystery to solve, but a doorway to the future, one that invites us to explore not only the Earth's hidden secrets, but the very nature of existence itself. Whether it leads to global cooperation, technological breakthroughs, or a deeper understanding of the universe, we must be ready for whatever it reveals. The journey into the unknown is never easy, but it is a journey we must take, together. As we wrap up this exploration into one of the Earth's most mysterious and unsettling phenomena, remember, the truth is out there, and we're just scratching the surface. If you found this investigation as intriguing as we have, don't forget to like this video and subscribe to stay updated on all the latest discoveries and theories that could change our understanding of the world. Your support helps us dive deeper into the mysteries that lie beneath our feet and beyond the stars. Thank you for joining us on this journey, and as always, keep questioning, keep exploring, and stay curious.